Hello, everybody. 3.210. Woohoo! 3.210 is asking us to apply, which means to use, karyograms, pictures of our karyotype. Karyotype is um, our homologous chromosomes, all nicely organized and put in a nice line to determine two things. So we're going to look at the gender or the sex of the offspring and to see if there's any kind of genetic disorder like Down syndrome. So before we do that, one thing that's a little bit confusing is why does this karyogram look so much different than this one, right? Like here is obviously the pair for homologous chromosomes number 1, right? And here it looks like 2 X's for chromosome number 1. So like what's going on there? So if you remember way back when in cell division, we have to make copies of our DNA, right? So if you had a chromosome number 1 from your dad, and let's change the color to make it red, and you had a chromosome number 1 from your mom, so I'm kind of copying this one down here. Before the cell divides, we need to copy these, right? Because the new cell needs to have the same genetic information. So sometimes when we produce our karyograms, we're getting them when they're just before mitosis. So they have these, you see them in these replicated forms. So you might have it like this. So this, right, looks much like that. But I want you to understand that this is the same as this when we're talking about karyograms. So you may see that, you will see that on an IB quiz or test, either of these two ways. Okay, so let's start with gender. So we talked a little bit about X and Y chromosomes. So I think that's kind of easy. Let's look at the bottom right. On the bottom right down here we see that this individual has an X and it has a Y, so it must be male, right? But let's also look at any kind of chromosomal abnormalities that might be here. Oh, this looks good. A pair of 1s, a pair of 2s, a pair of 3s, a pair of 4s, a pair of 5, blah, 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 blah. What's down here? So it is possible that when your chromosomes separate, and let me bring over some guest speakers. So here's my 2 chromosomes. When your chromosomes separate, instead of one going to one side and one going to the other, they can both go to the same side. And what happens is you get a sex cell, sperm or egg, with 2 copies of the same chromosome. The other egg or sperm, will have nothing. So that's how this happens. We're going to talk in detail exactly how that works. My lights went out. Everything's okay. So we're going to talk in detail about how that looks in meiosis. So that's how that happens. So when you see 3 chromosome 21s, please remember that's Down syndrome. But there's also other mistakes that can happen. I've never seen them ask on an IB exam. But you can end up with extra sex chromosomes. In this individual, we have 2 X's and a Y. So that definitely makes some complicated physical appearances for sure as somebody develops into a male or a female, because they're going to have a combination of parts. And also, instead of having extra chromosomes, you can have a missing chromosome. So in this individual, we have an X, and that's it. No Y. And again, that definitely has some developmental effects. Another common type of genetic disorder is when you have 3 chromosome 13s. I think this is called Pallow syndrome. And that can also cause some different effects. These are all livable. There are some combinations, like if you had I don't know, I'm just making this up because I'm not really sure. But if you had 3 chromosome number 4s, a lot of times that's fatal and the offspring doesn't go to term. But these 2 types of trisomy 21 and trisomy 13, they're survivable, and the baby can have, a more or less normal life, maybe some complications, but can still go full term and be born. So that's how we use karyograms to determine gender and also any kind of